Good morning, everyone. I am Kritik Bangera, and today my topic for the presentation is Smart Gloves Controller for drones using Raspberry Pi and NodeMCU. These are the outlines of the presentation to cover all the aspects of our paper. The objective of this paper is to show how a gesture controller can effectively improve the flow of controlling a drone without any hesitation, and to explain how a gesture controller works with complementary filter for accurate angles. A drone is an unmanned aerial vehicle, also known as quadcopter. It is an integrated system that communicates with GPS and onboard sensors. Drone is essentially a flying robot that can be operated remotely or fly independently through software-driven networks. Unless the user has some prior knowledge, using a remote controller can cause confusion, which could result in a drone damage. Glove-based controllers, on the other hand, will alleviate many of these issues. Wearable devices are a fast-growing area of tracking body movements. It is possible to translate captured data from hand movements and gestures to commands. A major benefit of wearable gloves is that they are compliant with normal human movements. An elegant solution for controlling drone movement is the use of hand angles. The conventional drone flying interface, such as joysticks and keypads, require the pilot to expertise the tools. The discomfort of joystick and multi-axis controller can be removed, allowing everyone to fly at their first attempt. Glove-based controller let you interact or monitor any other tools through your hand movements. Let me describe how we made these gloves. The gloves is made up of leather. The glove is equipped with NodeMCU microcontroller and a 5-volt power source, which is ideal for NodeMCU. It has a 2700 mAh battery that lasts for around 3 to 4 hours on a single charge. The microcontroller, the micro USB connector connects the Node MCU microcontroller to the power source, and the MPU 6050 sensor is attached to the Node MCU. The prototype glove is approximately 300 grams in weight. Our proposed models. The complementary filter. A complementary filter is a simple filter that allows only a certain amount of data which is needed. A complementary filter has minimum frequency noise and errors, which is why we have used this filter. In the shown diagram, we are using 0.98 to get the 98% of the gyroscope values and 0.02 to get the 2% of accelerometer values. This will remove the value shift from gyroscope and the frequency noise from accelerometer. Combining and updating these two values with a 0.5-second delay gives accurate value of gesture angles. In the gesture controller gloves, the drone can be controlled simply by moving your hand. A hand-fixed accelerometer can sense the hand's movement, then transmit the signal to the microcontroller. As shown in the diagram, the value received by the node MCU is left. Then the Raspberry Pi will send this keyword to the simulator. The main mode of communication with the simulator is ESP8266. Thruster, elevator, aileron, and rudder are the basic controls for the drone. MPU 6050 generates these angles, which are subsequently transmitted to the microcontroller. These values are then translated into keywords such as left, right, up, and down. Converting these data to keyword makes programming a lot easier. When it comes to IoT-based messaging protocol, MQTT, MQ telemetry transport is yet the reliable and cheapest solution. MQTT is a machine-to-machine communication protocol that is used to send and receive data from different microcontroller or devices. It uses publish and subscribe method to communicate with each other. As NodeMCU is a main microcontroller mounted on the hand gesture controller, it is used to send data to the simulator via MQTT server wirelessly through the configured network. The connected monitoring device receives the specific keyword as a command from NodeMCU microcontroller using MQTT protocol. This command is used to arm, disarm, and control the thruster, elevator, aileron, and rudder of the drone. As soon as the NodeMCU controller is connected to the server, it keeps on sending keywords to the simulator. The simulator then modifies these angles and positions accordingly. The microcontroller should always be quick and power efficient when it comes to performance. All other existing gloves controller mentioned in this study utilizes either an Arduino Uno or an Arduino Nano, as stated in the table. Arduino-based microcontrollers run on 5V and have a clock frequency of 16 MHz, whereas NodeMCU runs on 3.3 volts and has a clock frequency of 80 to 160 MHz. NodeMCU also includes an ESP8266 Wi-Fi module built in, which can be used to monitor the device wirelessly. The user will need to purchase a separate Wi-Fi module for the Arduino-based microcontrollers. In comparison to Arduino-based microcontrollers, NodeMCU features additional GPIO and PWM pins. NodeMCU has up to 16 GPIO pins and 9 PWM pins, whereas Arduino-based microcontrollers have 14 GPIO pins and 6 PWM pins. As a result, NodeMCU is better alternative for the proposed gloves controller because of its extensive set of features. The primary goal of this research is to develop a new way of controlling a drone. Gesture controlled drone not only reduces the complexity of drone flying control, but also makes it more efficient and easier to use. These type of drone need a special receiver or a frequency translator to translate frequencies to normal command and vice versa. A drone communication can be done more efficiently and can respond to any gesture, which is recognized by NodeMCU, implemented with MPU 6050 6-axis sensors. It can also be used by a cloud-based server so that the drone can be controlled from anywhere, any place where there is a proper connection. As the sensor and microcontroller are light-weighted, they can be used for a longer time. The gesture controller makes it easier to control if the Wi-Fi is replaced with a Raspberry Pi, 3G or 4G and LTE based hat. The range of the drone can be increased at a wider range. We studied many papers, but these papers were the paper we found more important. That's it from my side. Thank you.